In this lecture we will discuss the list occurrence. The previous lecture we discussed the earliest occurrence, and this lecture we continue with the least occurrence and how can I find the critical event, how can I find the critical activities, and what should be the critical path. Sorry. So according to our the previous discussion of the lecture, we start from the earliest end node. Here the end node is 6, so you have to start your calculation from this node. How can I calculate, how can I start our algorithm? So least occurrence of the point 6 of the node 6, that should be equals to the earliest occurrence, equals 6. Clear? So it's given that the earliest occurrence of the node 6 is 25, so you have to start your backward pass algorithm from this 25. Next you have to find the least occurrence of 5. And how can I calculate this? Least occurrence of the node 5. You want to calculate the least occurrence of the node 5, that should be equals to the least occurrence of the node 6 minus the activity time of all the path from 5 to 6, and you should consider the minimum value. That is equals to minimum value of all the path from the list occurrence of the node 6, which is just previous of this, and minus how many different paths are there. So here h and the duration is 12, so you have to subtract 12 from this, so the result becomes 25 minus of 12, that is 13, and mention here. Next we find the least occurrence of say 4. How can I calculate the least occurrence of 4? Least occurrence of 4 equals to, you can move this 4 either from 6 or from 5. That should be the minimum of, because just previous node is 5 as well as 6, both are the previous node. The minimum of least occurrence of 5 minus t 4 to 5, that is the time duration of the activity from 4 to 5, and the another path is from 6 to 4. You can move directly from 6 to 4, so least occurrence of 6 minus the project duration time t, which is 4 comma 6, and the result becomes minimum of least occurrence of 5 is 13 minus 0, least occurrence of 6 is 25, and this one is only minus 1. So the minimum value is 13, so it should be exactly 13. Yeah, so here we use this 13 least occurrence of this. Next we find the least occurrence of the point 3 of the node 3. In that case, how many different paths are there? You have to recognize how many different paths are there. You can move from this to this. Just to calculate the least occurrence of 3, that is backward method. You can move from 2, you can move from 5, you can move from 6, but before we cannot calculate the least occurrence of 2, we should not calculate the least occurrence of 3. Exactly for that reason here we calculate the least occurrence of 2. This is a direct path. 13 minus of 8, that should be 5, so nothing to calculate here, so you have to move the least occurrence of 3. Calculate the least occurrence of 3. This least occurrence of 3, you can move in the 3 different path. One is from the 6, another one is from the 5, another one is from the 2. So you have to consider the minimum of least occurrence of 2 minus the project duration time t 2 to 3 sorry, least occurrence of 5 minus t 3 to 5 t 3 to 5 t 3 to 5, and the last one is least occurrence of 6 minus t 3 to 6 3 to 6. So least occurrence of 2, and the result is 5, and here is 3, so the result becomes is a 5 minus of 3. So you cannot move from this way. Sorry, wrong calculation here. That should not be happen. Sorry, because there is an arrow from this 5. So you just consider these two. Least occurrence of 5, that is 13 minus 2, that should be 11. That means this result becomes 11. And least occurrence of 6 minus t 3 6, that is 11. 25 minus of 11, that is 14, and minimum of 11 and 14 should be 11. So the least occurrence of 3 which is mentioned here 11. And how can I find the least occurrence of 1? You can move from this to this to this, then move from this to this, so it's a 6. And it's 5 minus of 5, the minimum of this is 0, so that is the procedure for finding the least occurrence of or the backward pass method. We have already mentioned that where the forward pass and backward pass are same, that activities is known as the critical activities and the corresponding part should be the critical path. So the critical event, how can I find the critical event? Where the forward pass and backward pass are same, this one is the another thing, this one is another, this one is another, and this one is the another case. So the critical event should be where the forward and backward pass are same, that is event 1, 2, 4, 5 and 6. Just here change our color, sorry, here we use the green color. This one, the critical event where the forward and backward activity, forward pass and backward pass value are same. And how can I find the how can I use this critical activity? Because activity is represented by the arrow, so this one is your activity, since here we not mention the activity here. If we draw the diagram according to this A, say it's A, then it's become A. Okay, A is your activity 2 to 4, that is D. Okay, so it's a dummy activity, and 5 to 6, the activity is represented by H. So ADH is your critical activity. And how can I find the critical path? A critical, just to join the critical activities by a line, we get the critical path. So the critical path becomes, sorry, so the critical path becomes, you can use the dark line, this, 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 and the last one is this. That is your critical activity. Okay, when the critical activity is delayed, then the project evaluation delayed. If the critical activity doesn't delay, in this case project evaluation should not be delayed. Okay, thank you. In the next lecture we will move more example relating to the part and how can I calculate the different problem of part and CPM, and how the effect in the critical activities is delayed. Thank you for listening and wait for the next lecture.